All right, so here's a few more examples. Here's how we're going to simplify radicals. So when we're simplifying radicals like the square root of 50, we want to look for a perfect square that goes into 50. And there's one, it's 25. 25 times 2. So we look for a perfect square. And then we're going to break this up into the square root of 25 times the square root of 2. We know the square root of 5. We don't know the square root of 2. So this square root of 25 becomes 5, and the square root of 2. So it's 5 times the square root of 2. That is simplified. Now notice this. It would not help us. This would not work to break this up into 10 times 5. Because if we break it up into the square root of 10 times the square root of 5, I don't know the square root of 10. I don't know the square root of 5. All right? So that doesn't help us. So when we're using this technique to rewrite radicals, we want to find a radical, a number that is a perfect square that we can take the square root of. So when we have the square root of 80, for example, we can think about some numbers. 4 goes into 80. We could break it into 4 times the square root of 20. However, there's another 4 that's hiding in here. 4 goes into 20 again. So that's a little clue that there's a bigger perfect square. So we want to pick the biggest perfect square. And if we go through our list of perfect squares, 1, 4, 9, 16, 25, 36, 49. We look for the largest perfect square. We can try 16. If 4 goes into the number or is a factor, then probably 16 might be also, or possibly, and it is. So 80 is 16 times 5. So 16 goes in there 5 times, so we can break this up into square root of 16 times the square root of 5. And that gives us 4 times the square root of 5. All right? Well, what about cube roots? Well, we can do the same idea for cube roots. We want to look for a perfect cube. What are our perfect cubes? Well, these red ones here are our perfect cubes. Perfect squares. Perfect cubes. Let's make a quick list. We had it in that table there earlier. 1, 2 to the third power is 8. 3 to the third power is 27. 4 to the third power is 64, and that's good enough. Well, which one of these is a factor of 32? Well, 8 is. 8 is a factor of 32. So we want to write this as 8 times 4. And so we can break this into 2 cube roots. All right? And that's going to give us, we know the cube root of 8. The cube root of 8 is 2. We do not know the cube root of 4. All right? Well, what if we have variables going on here? Well, what we're going to do here is we're going to break this up into some roots that we know. Now, this is a 5th root. Now, we know the 5th root of 32. That's 2. 2 to the 5th power is 32. I don't know the 5th root of x, so we're going to kind of rearrange this. It's all multiplication, so we can do that. I do know the 5th root of y to the 5th. We could do that because this is the 5th power. So we can break this up into the 5th root of 32, y to the 5th, times the 5th root of x. Now, I know the 5th root of 32 is 2, and the 5th root of y to the 5th is y. We can do that, but we do not know the 5th root of x because we don't know what x is. So that's the idea there. All right, so we're going to be breaking this into things that we can take the root of and things that we can't. All right, so let's take this a little further here. So we're going to use the radical product rule. Now, we're going to break this into two square roots again. It's all variables, okay? And so we got to think about what can we take the square root of? Well, we can take the square root of x squared. And so we could break this into x squared times x to the third. Well, we can actually go a little bit further. Okay, let's think about this here. The square root of x squared we know is x, or really the absolute value of x. Can we take the square root of x to the fourth? Well, x to the fourth is just x squared squared. So here, the outer square and the square root would cancel, leaving us with x squared. Okay. Can we take the square root of x to the sixth? Or let's say y to the sixth? Well, we can, because this is y to the third squared. Okay. When we have a power to power, we multiply. Y to the third squared is y to the sixth. So the square root of y to the sixth is really just y cubed. All right? So what we want to do is we want to break this up. We want all the x's and y's here, but we're going to break it up into some things that we can square root and some things we can't. So we're going to change this x squared. We want the largest one. Let's take x to the fourth. So x to the fourth times x to the first is x to the fifth. So we're going to rearrange this. This is all multiplication. So we're going to rewrite this as, including all the variables that we need, but we're just going to write in two spots. We can take the square root of this because it's even. We can't take the square root of this because the exponent's not. We can take the square root of y to the sixth. We just kind of saw that here. And we only have y to the sixth. I don't have any extra y, so I don't need any leftovers. And what about z? Well, the biggest power of z that we can square root would be z to the 12th. And so we'd have z to the 12th times z. So what do we get when we square root this? Well, at this stage, it would be best to rewrite this so we can convince ourselves of this. So I need to rewrite all of this as something squared. So we're going to have x squared. Y, because x squared is x to the fourth. Okay, what was the power on this y? How about y cubed? So y cubed, y to the third power squared, that would be third squared, that's going to be y to the sixth. And then z to the sixth. Okay? And then we've got xz. Okay, that leftovers that we have here. Now, we've rewritten, and we can check. X squared squared is x to the fourth. Y cubed squared is y to the sixth. Z to the sixth squared is z to the 12th. Power to power, we multiply. And then we can check, okay, we have 13 z's. We've got y to the sixth. We've got x to the 4 and x to the 1. That's x to the fifth. So it is all equivalent. And so what we can do now is this square root is going to cancel out that exponent. And so we're going to have x squared y cubed z to the sixth. And then we have some extras that we could not deal with, so they stay under the radical. All right? Let's try one more, a cube root. Well, here we want to break it up into things we can cube root and things we can't. All right? Well, the biggest cube root that goes into 54 is 27. 27 times 2 is 54. Okay, so we're going to write two radicals as a product. We've got 27 times 2. Okay, we've got x cubed right here. We can take the cube root of x cubed. We can do that. All right. What about y? Well, we can't take the cube root of y to the 8th. The power that we're going to keep needs to be a multiple of 3. And we'll see why in a second. So the largest multiple of 3 less than 8 is 6. So I'm going to put y to the 6th here, but I need to put my leftovers here. And so that's y to the 2nd. We're multiplying y to the 6th times y to the 2nd. If we put this together again, we'd have 8 y's multiplied. Now, what's the closest exponent to 22 that is a power of 3? That's going to be 21. And we'll have z to the first power, right? Okay, got to be careful with the z's and the 2's there. That's a 2. All right, so now, come on. Pen ran out of ink here. There we go. All right, so I'm thinking we can clean up this stuff here because this is 3 to the 3rd. So I'm going to rewrite this as something to the 3rd power. This is x to the 3rd power. So x and to the 3rd power. 3 to the 3rd power is 27. X to the 3rd power is x cubed. Now we got a y we need in here. And so y to the 2nd power, y to the 2nd cubed. We multiply when we're doing a power to a power, we multiply. And then z, 21 divided by 3 is 7. Okay? Z to the 7th cubed is z to the 21st. So this is equal to this. And then I'm going to copy down this leftovers, 2y squared z. And now we can take this cube root. This cube root's going to cancel out with this cubed, leaving all that stuff underneath. So we're going to have 3xy squared z to the 7th. And then we have times this cube root 2y squared z. And that's the idea. So when we're simplifying, whether it's with numbers or with variables, we're going to break it into things that we can take the root of and things that we can't. Things we can take the 3rd root of and things that we can't. Then we go ahead and we take the 3rd root. And the key here again is that these exponents are multiples of that index. That's the key. All right, well, I hope that helps. And we'll continue on. Hopefully with more experience, this will make more sense. Keep it up.